Hello, everybody. This is Saqib Alauddin, and I am a physics and a chemistry instructor. Today, the topic I'm discussing is E.M.F and P.D. So, at the end of this video, you'll be able to understand what is E.M.F, what is P.D, and of course, what is the difference between E.M.F and P.D. Before we understand what E.M.F and P.D is, we first need to remember that in a circuit, the charges which are actually moving are electrons. So we say electrons in a circuit move from the negative terminal of the battery towards the positive terminal of the battery. So remember, electrons in a circuit, they will always move from the negative terminal of the battery towards the positive terminal of the battery. On the other hand, we say that we assume that the positive charges will move from the positive terminal of the battery towards the negative terminal of the battery. So remember, in any electric circuit, we say the electrons move from negative to positive, and the positive charges are assumed to move from the positive terminal of the battery towards the negative terminal of the battery. Also remember that the SI unit, that is the System International, or more commonly known as the standard unit of charge, is Coulomb. And unit charge means charge of 1 coulomb. Now, when we say unit charge, we actually mean charge of 1 coulomb. Okay, so here is a fact. Electrons flow from the negative to the positive terminal of the battery. We say that the positive charges are assumed to flow from the positive to the negative terminal of the battery. Now, why am I writing the word assume? Remember, in any circuit, the material possesses two charges, electrons and protons. Remember, neutrons are neutral. Now, protons are inside the nucleus, and you do not expect protons to come out of the nucleus and start moving in a circuit. So in reality, protons actually do not move. It's the electrons which move from the negative terminal of the battery towards the positive terminal. But in electricity, we assume that the same amount of positive charge is flowing from the positive to the negative terminal. And remember, the direction of current is same as the direction of flow of the positive charges. So in this circuit, if you ask me what is the direction of the flow of current, I will say current is traveling from the positive terminal of the battery all the way. It moves on the current and will move towards the negative terminal of the battery. Let's now understand what is E.M.F. E.M.F stands for electromotive force. Electromotive force. Now remember, E.M.F is of a cell or of a battery. So, for example, in this case, we say the E.M.F of this cell is 10 volts. First thing, remember, this battery or a cell that you have in the circuit, what is it? Remember, this battery or a cell is a source of energy. Battery or a cell is a source of energy. A battery or a cell, actually, what they do is they convert a non-electrical energy to electrical energy. Okay, now you need to understand what it exactly meant when we say a non-electrical energy is converted to electrical energy. See, in this case, you have a 10-volt battery, which means 10-volt battery means 10 joules of electrical energy will be converted to electrical energy. Electrical energy per unit charge. Let me explain you this. Every 1 coulomb charge will get 10 joules of electrical energy. Remember, when I say non-electrical energy is converted to electrical form, it means that the charge will possess that energy. So, for example, the most common type of cells that you have around are electrochemical cells. Now, what are electrochemical cells? The cells that you use in the remote controls of electronic devices or in your watches. Now, the most common type of cells, as I said, are electrochemical cells, right? What happens in them? When I say an electrochemical cell of 10 volt, I mean they convert 10 joules of chemical energy to electrical energy for every 1 coulomb charge. Remember, for every 1 coulomb charge. And why so? What do the charges do with this energy? These charges will use this energy to move through the complete circuit. So that means every 1 coulomb charge, now this is 1 coulomb charge, what happens? It gets 10 joules of energy. And what do they do with this energy? They move through the circuit. And when I say, it means that they continue to move and they reach from where they started. That means when I say the charge gets energy from the battery and they use this energy to be driven through the whole circuit. So when I say EMF, it means it is the energy provided by the battery to the charges, and this energy is used by the charges to move through or to be driven through the complete circuit. 10 volts would mean 10 joules of non-electrical energy converted to electrical form. This electrical form of energy is possessed by the charge. They will use this energy and they will move through the complete circuit. By the way, electrochemical cells are just one example of the cells that I've given, and they possess chemical energy. This chemical energy is the energy present in the electrolyte. There are other type of cells. Now, I'll give you an example. Solar cells. Solar cells will use energy from sun, and they will convert that energy to electrical energy. In a nuclear power plant, for example, when you have nuclear power plants, they also produce electricity. They use the nuclear energy from radioactive source, and ultimately it is converted to electrical energy after undergoing series of steps, and that electrical energy means the charges are then made to move in a circuit. So whatever a cell or a battery or a generator for that sake is, they use any non-electrical form of energy and they convert to electrical energy, which in other words means that they give energy to the charges to move in a particular direction in a circuit. Another very important aspect of EMF is you can also say that this non-electrical energy which is converted to electrical form is actually equal to the work done. So you can also say it is equal to the work done. Work done by whom? Work done by the charges. In doing what? In moving through the circuit. So remember, non-electrical energy which is converted to electrical form is equal to the work done. So here is the definition. You can define it in a way that EMF of a source means cell or a battery, is defined as the non-electrical energy converted to electrical energy per unit charge. That means for every 1 coulomb charge. To do what? To drive it through a complete circuit. Or you can say it's the work done by the source. Source means a battery or a cell. To do what? To drive a unit charge through a complete circuit. Learn the definitions. Examiner may ask you to write these definitions, so you can write either of them. Both mean the same thing. Let's now understand the concept of potential difference. Potential difference, short form PD. Okay, for example, we have a resistor and we say that the potential difference across this resistor is 5 volts. Okay, which means when 1 coulomb charge is moving through this resistor from one point, of course, to the other end, it will dissipate, it will consume 5 joules of energy, which means 5 volts means every 1 coulomb charge will dissipate or consume 5 joules of energy. Now, what do we mean by dissipate or consume 5 joules of energy? This means that the charge had 5 joules of electrical energy, and this electrical energy is converted to some other form. Now, when I say some other forms, usually it is heat. When this 1 coulomb charge is passing through this resistor, it is using up this energy, or you can say it is doing work in passing through the resistor. And what is the amount of work done by every 1 coulomb charge when it passes through the resistor? It's 5 joules. So simply, see what happens. What can I say? I would rather use 5 joules. I'll say 5 joules of electrical energy is converted to I would rather say to non-electrical form, example heat, by every 1 coulomb charge as it passes through this resistor. So you see, it's the other way around. In this case, the electrical energy is converted to non-electrical form. Remember, there are some other words that we can use instead of the energy conversion. So we can say this energy converted, remember, we can say energy converted. There are some other terms that we use in physics for this, or you can say energy dissipated, because remember, when it converts to heat, it is lost to the surrounding. So dissipated means lost to the surrounding. Or simply we can say work done, because whatever is the energy dissipated is equal to the work done. So repeating this point, 5 volts of PD across the resistor means when 1 coulomb charge passes through this resistor, it will dissipate 5 joules of energy in the form of heat, or you can say it will convert 5 joules of electrical energy into non-electrical form, that is, as I said, usually heat, or you can say it does work of 5 joules when it passes through the resistor. So the definition, you must learn this. The definition is, it is the electrical energy converted to non-electrical form by a unit charge. Unit charge, I told you, is a charge of 1 coulomb as it passes through a component, example resistor. Or you can simply say it is equal to the work done by a unit charge as it passes through a component. Component can be anything. It can be a resistor, it can be a lamp, it can be a buzzer, it can be a thermistor. So anything which is part of an electrical circuit is a component. Okay, in the end, the formula to calculate EMF or PD, it's work done or energy upon charge. Remember, when you are calculating EMF, the energy is non-electrical to electrical by the battery or a cell. But when you calculate PD, it's the electrical converted to non-electrical form. Either way, the formula is same, work done or energy upon charge, simply written as W or E upon Q. Q is the symbol for charge and W and E are the symbol for work and energy. Remember, we generally represent both EMF and PD by V, commonly known as voltage. The standard unit for both EMF and PD is volts, and 1 volt means 1 joule of energy converted or 1 joule of work done per 1 coulomb charge. So I hope all of you understood the concept of EMF and PD, and in my next videos, I'll continue to talk about further concepts in physics. Thank you.